Hello friends, now we'll start the next question. Question number 7. Differentiate the following with respect to x, and the first example is cot inverse of cot of e raised to x square. Now here let y is equals to cot inverse of cot of e raised to x square. We know that cot inverse of cot of theta is theta, and by using that formula you will get here y is equals to, that is e raised to x square. What was that formula? The formula is cot inverse of cot of theta, that is equals to theta. Now differentiate this with respect to x. Differentiate with respect to x. Derivative of e raised to x is e raised to x. But there is e raised to x square. It's a composite function. Therefore, first derivative of e raised to x square is e raised to x square into d dx of x square. Therefore, I will write here dy by dx is equals to derivative of e raised to x square is a e raised to x square into d dx of x square. And what is the derivative of x square? E is a 2x, and I will write here 2x into e raised to x square, and hence the dy by dx, dy upon dx, that is equals to 2x into e raised to x square. And now this is the answer. Now the next question. Here is the next question. Cos inverse of in root of 1 plus cos x upon 2. Again the solution. Let y is equals to cos inverse of in root of 1 plus cos x upon 2. But we know the formula. What is the 1 plus cos of a? 1 plus cos of a is equals to 2 cos square a by 2, whatever the angle, divided by 2. And therefore here I will write here, that is the cos inverse in bracket in root of 2 cos square x upon 2, and this whole divided by 2. And now here this 2 get cancelled, and you will get, that is a root of cos square x by 2, means you will get cos of x by 2. Therefore y is equals to cos inverse of in bracket cos of x upon 2, and that is equals to x upon 2, means y is equals to x upon 2. Here y is equals to x upon 2. Now differentiate this with respect to x. Differentiate with respect to x. Therefore dy by dx, what is the derivative of x? The derivative of x is 1, and therefore it is a 1 upon 2, and hence the answer, that is a dy by dx is equals to 1 upon 2. We will take the next question. Now the next question is tan inverse of 1 minus tan of x by 2 upon 1 plus tan of x by 2. Now we will express this one, that is the tan of pi by 4. And what about the denominator? Here denominator, that is a 1 plus 1 into tan of x by 2. Then 1 means what? Tan of pi by 4. Then we will express in terms of the tan form. Now see this here. Let y is equals to tan inverse of 1 minus tan of x upon 2 upon 1 plus tan of x upon 2. Okay. Now here, what is here? This 1 means what? Tan of pi by 4, because tan pi by 4 is 1. And I will write here 1 into tan of x by 2. But here again 1 means what? Tan of pi by 4. Therefore here tan of pi by 4 minus tan of x by 2 upon 1 plus 1 into tan of x by 2. But this 1 means what? Again tan of pi by 4 into tan of x upon 2. And here we will apply the formula. What is that formula? Tan of x minus y. Tan inverse of x. Tan of x minus y is equals to tan of x minus tan of y upon 1 plus tan x into tan y. By using this formula, you will get here y is equals to here tan inverse, and this is tan of pi by 4 minus x upon 2. What is formula for the tan of a minus b? Tan of a minus b means what? Tan a minus tan b upon 1 plus tan a into tan b. Now tan inverse of tan of theta, that is equals to theta. By using that formula, here you will have, that is a pi by 4 minus x by 2. Now differentiate this with respect to x. Differentiate with respect to x. Therefore dy by dx is equals to derivative of pi by 4. It's a constant. Its a derivative is 0, and derivative of x is 1. Therefore it is a 1 upon 2, and overall this is the minus 1 upon 2, and hence dy by dx is equals to minus 1 upon 2, and this is answer. Okay. Now we'll take the next problem. Now the next problem is tan inverse of 1 plus cos of x by 2 upon sine of 1 plus cos of x by 3 upon sine of x upon 3. Now see this again here. Let y is equals to tan inverse of 1 plus cos of x upon 3 upon sine of x upon 3. Now here we will apply the formula 2 for please. What is that? The first result is 1 plus cos of a is equals to 2 cos square a by 2. 1 plus cos of a is equals to 2 cos square a by 2. What about the second? Second is sine of theta is equals to 2 sine theta by 2 into cos of theta by 2. Now using this result, we will solve this problem. See this here. Therefore y is equals to tan inverse of, what is the 1 plus cos of x upon 3? Now see this here, 1 plus cos of a is equals to 2 cos square a by 2. That is whatever the angle divided by 2. In the same way here, that is x by 3 upon 2. Means you will get, that is a 2 cos square x upon 6. Here I will write here 2 cos square x upon 6. And what about the sine of x by 3? Again, that is a 2 sine theta by 2 into cos theta by 2. Means whatever the angle divided by again 2. Therefore, I will write here 2 sine of x upon 6 into cos of x upon 6. And here, now again here 2 and 2 to get cancelled. Cos square x upon 6 and here 1 cos, here cos x by 6 and here 1 cos x by 6 get cancelled, and you will get tan inverse of 1 cos of x by 6 and here sine of but what is the cos of theta upon sine theta? It's a cot theta, and hence here you will get, that is a tan inverse of cot of x upon 6. Now again the cot of theta is equals to pi by 2 minus tan of pi by 2 minus theta by using that formula. We'll write here, that is y is equals to tan inverse of tan of pi by 2 minus x upon 6. Now again tan inverse of tan of theta is theta, and therefore this equals to, that is the pi by 2 minus x upon 6. X upon 6. Now here y is equals to pi by 2 minus x upon 6. Now differentiate this with respect to x. I will write here, differentiate this with respect to x. Differentiate with respect to x. Therefore, dy by dx is equals to dy by dx is equals to pi by 2 is a constant, its derivative is 0, and the derivative of x is 1, that is a minus 1 upon 6, and hence dy by dx is equals to minus 1 by 6, and hence the answer is dy by dx is equals to minus 1 by 6. Which formula we use here? 1 plus cos of a is equals to 2 cos square a by 2. What about the sine of 2 times theta? 2 sine theta into cos theta. Similarly, sine of theta only 2 sine of theta by 2 into cos theta by 2. Okay, now we'll take the next problem. Now the next problem is tan inverse of cos of 7x upon 1 plus sine of 7x. Now first we convert this cos of 7x in terms of sine and this sine of 7x in terms of cos. Now see this here. Let y is equals to tan inverse of cos of 7x upon 1 plus sine of 7x. And now this can be written as tan inverse of, okay, tan inverse of sine of pi by 2 minus 7x upon 1 plus cos of pi by 2 minus 7x. Now again, what is the sine theta? Sine theta is 2 sine theta by 2 into cos theta. By using that formula, y is equals to tan inverse of 2 sine of whatever the angle divided by 2. Therefore here divided by 2 means what? Pi by 2 upon 2 means what? Pi by 4 minus 7x upon 2 into cos of pi by 4 minus 7x upon 2. Again this whole divided by 1 plus cos of pi by 2 minus 7x means what? 1 plus cos of 2 cos square x by 2. Therefore I will write here 2 cos square, okay, 2 cos square whatever the angle divided by 2 means here you will get pi by 4 minus 7x upon 2. Okay, bracket is completed. 1 cos will get cancelled and hence here you will get, that is a tan inverse of, okay, 1 cos 2 get cancelled, you will get sine of pi by 4 minus 7x upon 2 and to the denominator. What is denominator? That is the cos of pi by 4 minus 7x upon 2. Now what about here? This is the tan, that is y is equals to tan inverse of tan of pi by 4 minus 7x upon 2. Now tan inverse of tan of pi by 4 minus 7x upon 2 is, that is the y is equals to pi by 4 minus 7x upon 2. Now again differentiate this with respect to x. See this here. Differentiate this with respect to x. Differentiate with respect to x. Therefore, dy by dx is equals to derivative of pi by 4. Derivative of pi by 4, it's a constant. Its derivative is 0 minus derivative of x is 1. That is the 1 into 7. That is 7 upon 2. Here 7 upon 2, and hence dy by dx is equals to minus 7 upon 2, and this is the answer. Dy by dx is equals to minus 7 upon 2. Now we'll take the next problem. Now the next question is tan inverse of cosec x plus cortex. Again, let y is equals to, cosec x plus cot x, that is equals to tan inverse cosec x means what? 1 upon sin x, and cot means what? Cos x upon sin x. Both of them have the same denominator, and that is tan inverse of, in bracket, that is the same denominator, therefore we will write here 1 plus cos x upon sin x, 1 plus cos x upon sin x, and again the formula 1 plus cos of a is equals to 2 cos square a by 2. In a similar way here, that is the tan inverse 1 plus cos x means what? 2 cos square x upon 2, and the sin x is 2 sin x by 2, 2 sin x by 2 into cos of x upon 2. Okay, now here 2 get cancelled, 1 cos will get cancelled, you will get cos x by 2 upon sin x by 2, and that is here tan inverse of cos of x by 2 upon sin of x by 2. This 2 get cancelled and 1 cos, and overall here you will get tan inverse of cot of x upon 2. Okay, and this is equals to y. Now again this will convert this cot in terms of tan, that is a tan inverse of, okay, tan inverse of tan of pi by 2 minus x upon 2, tan inverse of tan of pi by 2 minus x upon 2, and here we have y is equals to tan inverse of tan theta is theta. In a similar way, here you will get pi by 2 minus x upon 2. Now differentiate this with respect to x. Therefore, dy by dx is equals to, what about the derivative of pi by 2? It's a constant, it's a derivative 0, minus derivative of x is 1 upon 2, and therefore dy by dx is equals to minus 1 upon 2. Okay, its a derivative is minus 1 upon 2. I will take the next problem. Now see this here, next problem. Sin inverse of 4 sin x plus 5 cos x upon root of 41. Now here let y is equals to sin inverse of 4 sin x plus 5 cos x upon root of 41. Again this can be written as sin inverse in bracket, that is a 4 upon root of 41 into sin x plus 5 upon root of 41 into cos x. Now here we will convert this total in terms of sign. For that we have to consider some things. Now consider this is the right angle triangle. Now we want to express this is nothing but the expansion of sin of a plus b, and for that I am considering here the triangle ABC. This is the ABC, and here, as here is a sin x, here must be the cos x. Therefore, I will write here alpha. But what about the cos of alpha? Cos of alpha means what? Adjacent side upon hypotenuse. Means this must be the adjacent side, and this is 4, and the hypotenuse is a root of 41. And the opposite side, this must be the 5. Now from this triangle, we have, that is the cos of alpha is equals to, cos of alpha is equals to 4 upon root of 41. Okay, this is the first one. And what about the sin alpha? Sin alpha, sin of alpha is equals to 5 upon root of 41. Now we will substitute these values, then you will get here y is equals to sin inverse of, I will write here first sin x, okay, sin x into 4 upon root of 41, this is nothing but the cos of alpha, plus cos x. And what about the 5 upon root of 41? And this is the sin alpha. Okay. Now this is the expansion of sin of a plus b, means sin of x plus alpha. Therefore, I will write here y is equals to sin inverse of sin of x plus alpha. Okay. Now sin inverse of sin of x plus alpha, and that is equals to y is equals to x plus alpha. Y is equals to x plus alpha. Now differentiate this with respect to x. Differentiate with respect to x, and therefore dy by dx is equals to dy by dx is equals to, now the derivative of x is 1, alpha is a constant, its a derivative is 0, and hence our answer dy by dx, that is equals to 1. In this type of the problems, we want to consider the right angle and express this in terms of the sine or the cos. Okay, now we'll take the next problem. Now the next problem is also similar. Sin inverse of cos of root x plus sin of root x upon root 2. Now here again, let y is equals to sin inverse of cos of root x plus sin of root x, and this whole divided by root 2. Okay. Now again this can be written as sin inverse of, here 1 upon, I will split up this 1 by root 2 into cos of root x plus, again split up this 1 upon root 2 sin of root x. Now for our convenience, that is here I will take, that is a 1 by root 2 means what? Sin of pi by 4. I will write here 1 by root 2, that is sin of pi by 4 is equals to cos of pi by 4, and that is equals to 1 upon root 2, and hence I will write here sin inverse of 1 by root 2 means what? Sin of pi by 4 cos of root x, and here 1 by root 2. Instead of that 1 by root 2, I will write here cos of pi by 4, and here again sine of root x, sine of root x. Now this is the expansion of sine of a plus b. But what is a here? A is a pi by 4 and b is a root x, and therefore I will write here sine of pi by 4 plus root x. Okay, now y is equals to sine inverse of sine theta, that is nothing but pi by 4 plus root x. Now differentiate this with respect to x. Differentiate again with respect to x. What is the dy by dx? There is a constant pi by 4. Pi by 4, derivative of constant is 0, therefore derivative of pi by 4 is 0, and we know the derivative of root of x is 1 upon 2 times root x, that you have learned in 11th standard. Therefore this is 1 upon 2 times root x, and therefore dy by dx is equals to 1 upon 2 root x, and this is the answer. Now we'll take the next problem. Now the next problem is cos inverse of 3 cos of e raised to x plus 2 sine of e raised to x upon a root of 13. Now see this here again. Let y is equals to cos inverse of 3 cos of e raised to x plus 2 sine of e raised to x, this whole divided by 13. Again this can be written as y is equals to cos inverse of 3 upon a root of 13 cos of e raised to x plus 2 upon a root of 13 sine of e raised to x, bracket complete. Again here we will consider the right angle triangle. Now see this here. Okay, this is triangle ABC. Measure of this angle is alpha. As here is a cos inverse, therefore bracket will try to, in bracket it must be the expansion of the cos of a plus b or a minus b, whatever that. Now see this here, cos alpha, that is here 3 upon root of 13. We require here cos. Then what is the cos alpha? That is the adjacent side, and this is the hypotenuse. Hypotenuse is root of 13 and opposite side is 2. Now from this triangle we will write here, that is a cos alpha is equals to 3 upon root of 13. 3 upon root of 13. And what about the sin alpha? Sin alpha is equals to opposite side upon hypotenuse, that is a 2 upon root of 13. Okay, now we'll substitute here. Therefore you will get here y is equals to cos inverse of, what about here, cos alpha. First of all I will write here cos of e raised to x into cos alpha plus, what about here, sine of e raised to x into sine of alpha. Therefore, here y is equals to cos inverse of. Now this is the expansion of cos of a minus b. What's the cos of a minus b? Cos a cos b minus cos of a minus b is a cos a cos b plus sin a sin b. Therefore, this is the expansion of cos of a minus b. Here we take a as e raised to x, okay, and the b as alpha. Now cos inverse of e raised to x minus alpha, and this is y is equals to e raised to x minus alpha. Now differentiate this with respect to x. Therefore, dy by dx is equals to, what is the derivative of e raised to x? The derivative of e raised to x is e raised to x. And what about the alpha? Alpha is constant, its derivative is 0, and therefore dy by dx is equals to e raised to x, and hence the answer. Therefore dy by dx is equals to e raised to x. Now we take the next problem. Now with the proper substitution, the given inverse function may be reduced to the simple form, and then we can differentiate it easily. Now what are that proper substitutions? Now see this here. The first is in root of x square minus a square minus x square. Then what is the substitution? You may take x is equals to a sin theta or x is equals to a cos theta. Next, in root of a square plus x square, then x is equals to a tan theta or x is equals to a cot theta. Next, in root of x square minus a square, then x is equals to a sec theta or x is equals to a cosec theta. Now how to remember this? You know the derivative of sine inverse of x, that is 1 upon in under root of 1 minus x square, means what? Constant square minus variable square, and here is a constant square minus variable square, then x is equals to a sin theta or x is equals to a cos theta. Now what is the derivative of tan inverse of x? That is 1 upon 1 plus x square. That is 1 means what? The constant square plus variable square, and here is also that, but you will say that the radicand side, but omit it radicand side for the time being. You can have the a square plus x square, then x is equals to a tan theta or x is equals to a cot theta. Next is in root of x square minus x square. What is again the derivative of sec inverse and cosec inverse? That you have, that is a x in under root of x square minus 1. X square minus 1 is important. 1 means what? 1 square, and here x square minus a square. Therefore you can remember like this also, x is equals to a sec theta or x is equals to a cosec theta. Next is in root of a plus x upon a minus x or a minus x upon a plus x. Then x is equals to a cos of 2 times theta or x is equals to a cos theta. Next is instead of this a, we have replaced here 1 in under root of 1 plus x upon 1 minus x or 1 minus x upon 1 plus x. Then you have substitution x is equals to cos theta or x is equals to cos of 2 times theta or x is equals to cos theta. Next is also very important. These are similar substitutions. See this here, 1, 2, 3. Okay, x is equals to a cos of 2 times theta, x is equals to cos of 2 times theta, x square is equals to, okay, here is x square, that's why here taken x square is equals to a cos of 2 times theta or x square is equals to a cos of theta. These are the substitution. And now this also very nice, simple. 2x upon 1 minus x square and 2x upon 1 plus x square. Okay, and or 1 minus x square upon 1 plus x square, then you have this option x is equals to tan theta 1 minus 2x square, or 3x minus 4x cube. You know the formula for the sine of 3 theta. Sine of 3 theta is equals to 3 sine theta minus 4 sine cube theta. In similar way, you can remember this. But what about the cos of 3 theta? Cos of 4 theta is a 4 cos cube theta minus 3 cos theta, and in this way 2x square minus 1 is equal and 4x cube minus 3x have the substitution x is equals to cos of theta, and the next is 3x minus x cube upon 1 minus 3x square, and what is the substitution? X is equals to tan theta, and this is nothing but the formula for the tan of 3 times theta. What is the tan of 3 times theta? That is the tan of 3 times theta is equals to 3 tan theta minus tan cube theta upon 1 minus 3 tan square theta, and you can remember this also in this way. And these are very important formulas when we have the problem of the inverse differentiation, and if we substitute, then problem can be easily solved. We can differentiate it easily. Now we'll take the next question depending on this substitution. Now the first problem is cos inverse of in bracket 1 minus x square upon 1 plus x square. Now it's a solution. Let y is equals to cos inverse in bracket 1 minus x square upon 1 plus x square. Now what is the substitution here? That is a put x is equals to put x is equals to tan theta. Put x is equals to tan theta, and it means that theta is equals to tan inverse of x. Okay, and therefore our expression will become y is equals to cos inverse of 1 minus tan square theta upon 1 plus tan square theta. But we know the one of the important formula. What is that? Cos of 2 times theta. Cos of 2 times theta is equals to 2 cos square theta minus 1 minus 2 sin square theta, or 1 minus tan square theta upon 1 plus tan square theta, and this is nothing but that is a cos inverse of what is here? Cos of 2 times theta. Now cos inverse of 2 times theta means what? Y is equals to 2 theta. But what is the theta? Theta is tan inverse of x. Theta is tan inverse of x. Therefore y is equals to 2 into tan inverse of x. Now differentiate this with respect to x. Differentiate with respect to x, and therefore dy by dx is equals to derivative is a constant. The derivative of tan inverse of x is 1 upon 1 plus x square, and that the answer, that is 1 upon 2 upon 1 plus x square. Okay, 1 into 2 is 2, and hence we will write here answer, that is the dy by dx is equals to 2 upon 1 plus, here is the x square, and this is the answer. Okay, now we'll take the next problem. Now the next problem is sine inverse of 1 minus x square upon 1 plus x square. Now the same substitution, that is here, first of all let y is equals to sine inverse of 1 minus x square upon 1 plus x square. Okay. Now what is the substitution? Put x is equals to tan theta, and therefore theta is equals to tan inverse of x, and therefore you will have this, that is a sine inverse of, in bracket, 1 minus tan square theta upon 1 plus tan square theta. Again the same results. Cos of 2 times theta means what? 2 cos square theta minus 1 minus 2 sin square theta, and the last is 1 minus tan square theta upon 1 plus tan square theta, and this is nothing but the cos of 2 times theta, and therefore I will write here y is equals to sine inverse of cos of 2 times theta. Okay, now here is the cos of 2 times theta and here is the sine inverse. Therefore we will convert this cos of 2 times theta in terms of the sine theta, and it is written as y is equals to sine inverse of, in bracket, sine of pi by 2 minus 2 theta, and y is equals to sine inverse of sine of theta means what? That is pi by 2 minus 2 theta. I will write here pi by 2 minus 2 theta, and here we have y is equals to pi by 2 minus 2 theta. What is the theta? Theta is the tan inverse of x, and here tan inverse of x. Now differentiate this with respect to x. This is very simple form. Differentiate with respect to x, and hence dy by dx, dy by derivative of the constant pi by 2 is 0. 2 is a multiplicative constant, keep it as it is, and derivative of tan inverse of x is 1 upon 1 plus x square, and hence dy by dx is equals to, that is a minus 2 upon 1 plus x square. Okay, minus 2 upon 1 plus x square, and again we write here in bracket, square bracket, and this is the answer. Now we'll take the next problem. Now the next problem is cos inverse of 3x minus 4x cube. Now what will the substitution? This is nothing but the formula, that is the sine of 3 theta is equals to 3 sin theta minus 4 sin cube theta. Therefore here the substitution must be, that is the x is equals to sin theta. Now first of all, let y is equals to cos inverse of 3x minus x cube. Put x is equals to sin theta, and therefore what about the theta is equals to? Theta is equals to sine inverse of x, and therefore this can be written as, that is a cos inverse, in bracket, 3 sin theta minus 4 sin cube theta, and therefore that is equals to cos inverse 3 sin theta minus 4 sin cube theta, and this is nothing but sine of 3 theta, and sine of 3 theta, here is a cos inverse, therefore we can write it, that is a cos inverse in bracket cos of pi by 2 minus and 3 theta. Now cos inverse of pi by 2 minus 3 theta is nothing but that theta means pi by 2 minus 3 theta. Now we substitute the value of theta. What is the theta? Sin inverse of x, and therefore here we have y is equals to, okay, y is equals to pi by 2, y is equals to pi by 2 minus 3 sin 3 theta means what? Sin inverse of x. Okay, substitute the value of this theta. Now differentiate this with respect to x. This very simple form. Differentiate with respect to x, and therefore dy by dx is equals to 0 minus, what is the derivative of sin inverse of x? That is a 1 upon in root of 1 minus x square, and hence dy by dx is equals to minus 3 upon in root of 1 minus x square. Okay, minus 3 upon in the root of 1 minus x square. Okay, now this is the answer. We take the next problem. Now again the next problem, that's also very simple. Cos inverse of 1 minus 9 raised to x upon 1 plus 9 raised to x. Again the substitution. Let y is equals to cos inverse 1 minus 9 raised to x upon 1 plus 9 raised to x. Now this 9 raised to x means what? 3 raised to x bracket square. Therefore cos inverse in bracket 1 minus 3 raised to x bracket square upon 1 plus 3 raised to x bracket square. Again 1 minus variable square upon 1 plus variable square. Then what will be that substitution? That is a 3 raised to x is equals to tan theta. Therefore here we have put tan of theta is equals to 3 raised to x, and therefore theta is equals to tan inverse of 3 raised to x, and therefore y is equals to cos inverse in bracket 1 minus, okay, 1 minus tan square theta upon 1 plus tan square theta, and this is nothing but that is a cos inverse of, again this is the expansion of cos of 2 times theta, and therefore this is the cos of 2 times theta. Cos inverse of cos of 2 times theta, that is equals to 2 theta, and therefore y is equals to, what is the theta? Theta is a tan inverse of, here is a 2, theta is a tan inverse of 3 raised to x. Now differentiate this with respect to x. I will write here differentiate with respect to x. Therefore it's a derivative, that is a dy by dx is equals to 3. What is the derivative of tan inverse of x? That is 1 upon 1 plus x square. But here function is composite, and therefore here we write here 1 upon 1 plus 3 raised to x bracket square into ddx of 3 raised to x. Okay, and hence this is equals to, that is a 3 into, what is the derivative of 3 raised to x? 3 raised to x into log of 3. 3 raised to x into log of 3 upon 1 plus 3 raised to x bracket square. And you can have its simplified form. What is there? Oh, one more mistake in that. Here we write here 2. Okay. Yes. Therefore, the answer dy by dx is equals to 2 into 3 raised to x log of 3 upon 1 plus 3 raised to x bracket square, and we'll write in this bracket. And have the answer, that is a 2 into 3 raised to x log of 3 upon 1 plus 3 raised to x bracket square. Now we'll take the next example. Now the next problem is sine inverse of 1 minus 25x square upon 1 plus 25x square. Now the let y is equals to sine inverse in bracket 1 minus 25x square upon 1 plus 25x square. Now what is the substitution here? That is a put here 5x is equals to tan theta, and therefore theta is equals to tan inverse of 5x, and therefore y is equals to sine inverse 1 minus 25x square means what? 5x bracket square, and that is nothing but the, here I will write here 5x bracket square upon 1 plus 5x bracket square, and here y is equals to sine inverse 1 minus 5x means what? 1 minus tan square theta upon 1 plus tan square theta. Now 1 minus tan square theta upon 1 plus tan square theta, and this is again nothing but cos of 2 times theta, and that's why I will write here that is a cos of 2 times theta. Now sine inverse of cos of 2 times theta, therefore again it can be written as sine inverse of sine of pi by 2 minus 2 theta, and hence y is equals to sine inverse of y is equals to pi by 2 minus 2 theta. Now we will substitute the value of theta, therefore here we have y is equals to pi by 2 minus 2 theta, 2 here, 2 into theta means what? Tan inverse of 5x. Now differentiate this with respect to x. Differentiate this with respect to x, and therefore dy by dx is equals to 0 minus 2. Derivative of tan inverse of x is 1 upon 1 plus x square. Similarly here, derivative of tan inverse of 5x is 1 upon 1 plus 5x bracket square into derivative of phi x. Okay, derivative of phi x, and therefore dy by dx is equals to derivative of phi x is 5. 2 into 5, that is a minus 10 upon 1 plus 5x bracket square, or you may write here dy by dx is equals to minus 10 upon 1 plus 25x square, and again this can be written as that is a minus 10 upon 1 plus 25x square. I will take the next problem. Now the next problem is tan inverse of 2 into x raised to 5 by 2 upon 1 minus x raised to 5, and here again let y is equals to tan inverse of 2 x raised to 5 by 2 upon 1 minus x raised to 5. Okay, now the next is let, or put here, substitute here, put x is equals to x raised to 5 by 2 is equals to tan theta, and therefore theta is equals to tan inverse of x raised to 5 by 2. Okay, and therefore here y is equals to tan inverse of, in bracket, 2 tan theta upon, here x raised to 5 means what? It's a 5 by 2 bracket square, and here that is a 1 minus tan square theta, as here I will write here x is equals to x raised to 5 by 2 is equals to tan theta, therefore squaring on both sides, x raised to 5 is equals to tan square theta. That is the tan inverse of 2 tan theta upon 1 minus tan square theta, and here you will have tan inverse of, in bracket, tan of 2 times theta, and here you will have 2 theta. But what is the theta here? Theta is, that is 2 tan inverse of x raised to 5 by 2. Now we will differentiate this with respect to x. Differentiate with respect to x, and therefore dy by dx is equals to 2 upon 1 plus x raised to 5 by 2 bracket square into ddx of x raised to 5 by 2, and therefore dy by dx is equals to, the derivative of x raised to 5 by 2 is 5 by 2 into x raised to 3 by 2. Therefore here 2 into 5 by 2 into x raised to 3 by 2 upon, in bracket, 1, or you can write here 1 plus x raised to 5 by 2 bracket square means what? X raised to 5. Now here 2 get cancelled, and hence dy by dx is equals to, that is a 5 into x raised to 3 by 2 upon 1 plus x raised to 5, and this is the answer. Now we'll take the next problem. Now the next problem is tan inverse of 8x upon 15x square. Now the solution. Let y is equals to tan inverse of 8x upon 1 minus 15x square. And here, what are the two numbers such that whose sum is 8x and product is 15, 5x and 3x, and therefore this can be written as, that is a tan inverse of 5x plus 3x upon 1 minus 5x into 3x. Okay, 5x into 3x. And now what is the formula? Tan inverse of x plus y upon 1 minus x into y. Therefore here tan inverse of 5x plus tan inverse of 3x. Now differentiate this with respect to x. Differentiate with respect to x. Therefore dy by dx is equals to, that is 1 upon 1 plus 5x bracket square into ddx of 5x plus 1 upon 1 plus 3x bracket square into ddx of 3x, and hence dy by dx is equals to, derivative of 5x is 5 upon 1 plus 25 x square plus 3 upon 1 plus, here is a 9x square, and hence the dy by dx is equals to 5 upon 1 plus 25 x square plus 3 upon 1 plus 9x square, and this is the answer. We can write here. Okay, I will take the next example. Now the next problem is again tan inverse of 2 root x upon 1 plus 3x. Now here let y is equals to tan inverse 2 root x means what? 3 root x minus, I will write directly. What is the consideration? What are the two numbers such that whose sum is 2 root x and the product is 3x? The numbers are 3 root x minus root x, then you will get 2 root x, and product of there is, that is a 3x, that is a 3 root x into root x. Okay, therefore y is equals to, this is formula for tan inverse of a minus b upon 1 plus a into b, and here is a 3 root x minus tan inverse of root x. Now differentiate this with respect to x. differentiate with respect to x, and therefore dy by dx is equals to 1 upon 1 plus 3 root x bracket square into ddx of 3 root x minus 1 upon 1 plus root x bracket square into derivative of root x, and here we have that is a dy by dx. Derivative of root x is 1 upon 2 root x, and we can write here that is a 3 upon 2 root x in bracket 1 plus the square of 3 root x is 9x, okay, and next is minus 1 upon, again the derivative of root x is 1 upon 2 root x, therefore I will write here 2 root x and in bracket 1 plus x, okay, this is the derivative, okay, so right here and this is the answer. Now the next problem is tan inverse of 2 raised to x upon 1 plus 2 raised to 2x plus 1. Now here let y is equals to tan inverse of 2 raised to x upon, again this can be written as 2 raised to 2x into 2, okay, and here y is equals to tan inverse of 2 raised to x, here 1 plus 2 into 2 raised to x, that is a 2 raised to 2x means what? Here is 2 raised to x and this 2, and next is 1 2 raised to x is remaining, that is here. Now what are the two numbers such that whose sum is a 2 raised to x and the product is 2 into 2 raised to x into 2 raised to x, that is we can write here tan inverse of 2 into 2 raised to x minus 2 raised to x upon 1 plus 2 into 2 raised to x into 2 raised to x. Now tan inverse of a minus b upon 1 plus a into b, and therefore this can be written as that is a tan inverse of 2 into 2 raised to x minus tan inverse of 2 raised to x. Now differentiate this with respect to x, okay, differentiate with respect to x, and therefore dy by dx is equals to the derivative of tan inverse of 2 into 2 raised to x, that is 1 upon 1 plus 2 into 2 raised to x bracket square into ddx of 2 into 2 raised to x minus, okay, 1 upon 1 plus 2 raised to x bracket square into ddx of 2 raised to x, and therefore dy by dx is equals to, what is the derivative of 2 raised to x? 2 raised to x into log of 2, and therefore here 2 into 2 raised to x into log of 2, and here 1 plus 2 into 2 raised to x bracket square minus, again the derivative of 2 raised to x is 2 raised to x into log of 2, log of 2 upon 1 plus 2 raised to x bracket square, and this is the derivative. You can take the common, that is a 2 raised to x log of 2 as a common, and then you can simplify whatever that answer given in the textbook. Okay, now the next problem. Or suppose that if you want to write the answer according to the textbook, then you can write here, that is a 2 raised to x log of 2, take the common, then what will be in bracket, that is a 2 upon 1 plus 2 into 2 raised to x bracket square means what, 1 plus 4 into 2 raised to 2x minus 1 upon 1 plus 2 raised to 2x. You can have the answer also like this. I will take the next problem. Now here the tan inverse of A plus B tan x upon B minus A tan x. Now again here, let y is equals to tan inverse of A plus B tan x upon B minus A tan x. In our every formula, tan inverse of x plus y upon 1 minus x into y. Therefore, divide this numerator and the denominator by b, because here we required 1. If you divide the numerator and denominator by b, then you will get y is equals to tan inverse in bracket A upon B plus tan x upon 1 minus A upon B tan x. Now again this is the expansion of tan inverse of x plus y upon 1 minus x into y, and therefore here you will get tan inverse of in bracket A upon B plus tan inverse of tan of x. Now differentiate this with respect to x, but before that y is equals to tan inverse of A upon B, tan inverse of tan x is x. Now differentiate this, okay, differentiate with respect to x, and therefore dy by dx, is equals to derivative of constant tan inverse of A upon B. This is the constant, its derivative is 0 and the derivative of x is 1, and therefore dy by dx is equals to 1, and this is the answer. I will take the next problem. Now the next problem is cot inverse of 4 minus x minus 2x square upon 3x plus 2. Again here we can write, let y is equals to cot inverse in bracket 4 minus x minus 2x square upon 3x plus 2. Therefore again y is equals to, we can write here, tan inverse of 3x plus 2 upon 4 minus x minus 2x square. And which formula here? That is a cot inverse of x is equals to tan inverse of 1 upon x. Okay. Now see this. This is important. What is here a and b? To find out a and b, I will apply here denominator. See this here. That is a tan inverse here 3x plus 2. Keep it as it is first of all. Now from 4 you take 1 and take the minus sign common overall. 4 you have taken 1 and take minus sign from all the remaining. What is that? It is a 2x square plus x. Okay, and here the minus 3. Now you can factorize this. That is a 2x square plus x minus 3. That the product of these two is a 6. Therefore you will have 2x square plus 3x minus 2x minus 3, and you can take common, that is a x, then in bracket you will get 2x plus 3 and minus 1, again 2x plus 3, and therefore you will have 2x plus 3 and x minus 1, and therefore this can be written as, that is a y is equals to, here I will write here y is equals to tan inverse of this 3x plus 2 can be again written as 2x plus 3. 3x plus 2 can be written as 2x plus 3. This is first one. And what about the second? Second is plus x minus 1. And this whole divided by, what is that? The product of these two. That is a 1 minus 2x plus 3 into x minus 1. If you simplify this, then you will get this. Now here again the tan inverse of a plus b upon 1 minus a into b means you will get here, that is a tan inverse of, here you can write directly now 2x plus 3 in first bracket, and first next is a tan inverse of x minus 1. Now differentiate this with respect to x, and therefore dy by dx is equals to, that is a 1 upon 1 plus 2x plus 3 bracket square into derivative of 2x plus 3. What's the derivative of 2x is 2 and 3 is 0. Therefore 2 plus 1 upon 1 plus x minus 1 bracket square into derivative of x minus 1. The derivative of x minus 1 is 1, and hence the answer is, that is a dy by dx is equals to, it is a 2 upon 1 plus 2x upon 3 bracket square plus 1 upon 1 plus x minus 1 bracket square. And in this way we have completed the exercise 1.2. Now we'll see in the next video. Till then, goodbye.